In this video, we are going to discuss the Leontief static input-output model. There are two models, the open model and closed model. In this video, I am going to discuss the open model. For understanding purpose, before proceeding to n industries or nth number of industries, I am going to discuss first the three industries case, so that it will be easy for us to understand the model. The Leontief input-output model is a static model. Now, what is a static model? Static analysis is also known as equilibrium analysis. So, in equilibrium economics, we already know it is that state where there is no tendency to change of the economic variables. So there is a complete lack of tendency to change. It is for this reason that the equilibrium state or the study of what the equilibrium state looks like is referred to as statics. Now we have already studied market equilibrium. A market equilibrium is attained in such a manner where the supply and demand curve intersect each other, and in that manner the equilibrium point is attained. Now through the equilibrium point, which is derived by the intersection of the demand and supply curve, the equilibrium price and equilibrium quantity is obtained. So at that equilibrium point, there is no excess demand or excess supply. Now remember, in static analysis or equilibrium analysis, time element has nothing to do. All the economic variables refer to the same point of time. So what it means is that a static analysis or equilibrium analysis does not show how the equilibrium is attained. It merely discusses the point of equilibrium, or it merely tells us about the condition of equilibrium. Now before Leontief developed the input-output model, there were several attempts or several work of different economists, which has become the background of the input-output model, or the base we can say. Francois Cousnet has developed a cruder version of this technique called the tableau economique, and Leon Walras' work Elements of Pure Economics on General Equilibrium Theory was a forerunner and made a generalization of Leontief's seminal concept. However, in its modern version, the input-output analysis have been developed by the American economist Wassily W. Leontief in his famous work Structure of the American Economy in the year 1951. Wassily Leontief was a Russian-American economist famously known for his research on input-output analysis and how changes in one economic sector may affect the others. He won the Nobel Prize in Economic Sciences in 1973, and also 4 of his doctoral students have also been awarded the prize. Some of them include well-known economists like Paul A. Samuelson, Robert Solow, Vernon L. Smith, Thomas Schelling. Now, what does the input-output model tells us? Now at static level, that means at equilibrium level, referring to one data point, the input-output model deals with a particular question. What level of output should each of the nth industry produce in order that it will just be sufficient to satisfy the total demand for that product? So in this particular example, for understanding purpose, I have taken 3 industries. The industry are steel, automobile and oil. What the model tries to suggest us is that if there are 3 industries in an economy, how much should each of the industry produce so that it will just be sufficient to satisfy the total demand for that product. So as you can see in this diagram, we have 3 industries: the steel, the automobile and the oil industry. Now let us consider the steel industry. Steel is being demanded by the automobile industry and also by the oil industry. Now it is being demanded by the automobile industry for making of body parts and other requirements. Now steel products such as tank is being used by the oil industry for storage purpose. Now how much should steel industry produce depends on the total demand for it by automobile industry and oil industry. Now the input-output model says that the steel industry should produce that output level which is just sufficient to satisfy the total demand for it by the automobile industry and by the oil industry in this particular example. Now remember that the automobile industry and oil industry use steel as its intermediate input. Automobile industry has its own primary inputs and oil industry has its own primary inputs. The primary inputs for automobile industry may be labor and other raw materials required for manufacturing automobile. Similarly, for oil industry, it may be crude oil and several other raw materials. Now the same is the case for automobile industry and oil industry. So the input-output model says that the oil industry will produce that level of output which will just be sufficient to satisfy the total demand for it by steel industry and automobile industry. In the same manner, automobile industry will produce that level of output which will satisfy the total demand for it by steel industry as well as oil industry. The input-output analysis is a method of analyzing how an industry undertakes production by using the output of other industries in the economy and how the output of the given industries is used up in other industries or sectors. So it tells us how in the production of steel, the output of automobile industries goes into it and the output of oil industry goes into it. So steel industry may use the output of oil industry as its intermediate inputs for powering its machines. In the same manner, steel industry may use the output of automobile industry in transporting raw materials from one plant to another and also other raw materials. Now the output of steel industry is in turn being used by the automobile industry and oil industry. Now steel is being used as input by the automobile industry in making body parts of different automobiles, and also steel is being used as input, that is steel products such as tanks and others. It is being used as intermediate inputs for storage facility. The same argument goes for other industries as well. If you consider the oil industry, in addition to its primary inputs, oil uses steel products in its manufacturing process, that is for storage facility, and also uses automobile as its intermediate inputs for transportation purposes, such as from one plant to another or from one refinery to another. The output of oil industry is in turn used as input by automobile industry as well as steel industry. If we consider the automobile industry in its manufacturing processes, the output of steel industry is used as intermediate inputs such as in making body parts in addition to its primary inputs. Also, the automobile industry uses the output of oil industry for powering its machines. The output of automobile industry is in turn used as intermediate inputs by the steel industry for transportation purposes and also by the oil industry for transportation purposes from one refinery to another, and so on. In this manner, we can see that there is an interdependence between different industries. In our case, we are discussing the three industries. We see that there is a clear interdependence between the steel industry, oil industry and automobile industry. Now this interdependence between the different industries leads to an equilibrium between the supply and demand. The input-output analysis is also known as the inter-industry analysis, as it explains the interdependence and interrelationship among various industries. In other words, the input-output analysis explains the interdependence of inputs and outputs of various industries in the economy. Now let us understand what is an open model and a closed model. The commodity produced by N industries will be used as intermediate inputs, that is, inputs supplied by the N industries together with primary inputs. Primary inputs can be raw materials, land, labor, etc., which are not industrial products. If there are N industries in an economy, then the product of these N industries will be used as input demand of the same N industries, that is, which is to be used for further production of any commodity of the N industries. So what it suggests us is that the output of the three industries, in our example the steel, automobile and oil, the output of these three industries will be used as intermediate inputs in the same three industries, that is steel, automobile and oil will be used as intermediate inputs in these industries itself. Now some quantity of the commodity produced by the N industries will be used as final demand, that is, they will be consumed as final goods by consumers and not for further production. Consumers in this case may be the individual consumers, the government or export. In this particular example, we have assumed that the output of one industry is used as intermediate input in the other two industries and itself. There is no final demand for the product. However, in real world, the output of an industry is used as intermediate input in another industry as well as final good by consumers. So a closed model will be a model such as this particular example which we have discussed. So in this particular example, we have not taken into consideration the final demand for each industry. We have assumed that the output of each industry is used as intermediate inputs by the other two industry and by itself. So what is an open model? An open model is one in which the output of the n industries is used as intermediate inputs in the production of commodity in the n industries. So the output of steel is being used as intermediate input in the production of steel, oil and automobile industry. It also takes into consideration the final demand for the output of that particular industry. So this is an example of an open model. Now, part of the output produced by steel industry is being demanded by the oil industry and by the automobile industry as intermediate inputs. It is also being demanded by the consumers as final good. That is, steel roof is one of its output and it is being used by consumers as final goods. So an open model accommodates the activities of the n industries as well as those of consumer, households, government sector and foreign sector. If we consider the automobile industry, part of the output produced by the automobile industry is used as intermediate inputs by the oil industry as well as steel industry. It is also being demanded as final good by consumers. In the same manner, part of the output produced by oil industry is used as intermediate inputs by the steel industry and automobile industry. It is also being demanded as final good by consumers. Now let us look at some of the assumptions of the input-output model. Now the first assumption is that each industry produces only one homogeneous commodity, which implies that each industry produces only one similar commodity. So no industry can produce two commodities which are heterogeneous or which are different. The second assumption, each industry uses a fixed input ratio or factor combination for the production of its output. So in the production process of any industry, it uses a fixed input ratio or factor combination. So in the production of a steel industry, it uses a certain fixed ratio of oil and automobile. The third assumption, production in every industry is subject to constant returns to scale, so that a k-fold change in every input will result in exactly k-fold change in the output. Constant returns to scale implies that if we increase each input, in this particular production function we have Q is a function of L and K, that is labor and capital. So if we increase both labor and capital by 100%, so we increase labor by 100% and capital by 100%. If the resultant output increases by 100%, then it is known as constant returns to scale. Next, the fourth assumption, if an industry produces two different commodities or uses two different possible factor combinations, then that industry may be broken down into two separate industries. So say if a particular industry, let us consider the Reliance industry. Let us assume hypothetically that it deals only in oil and telecommunication. So in such case, we separate the two industry. We put the oil unit together with the oil industry and the telecommunication unit together with the telecommunication industry. In the same manner, if an industry uses two different possible factor combinations, we can use the same example. The Reliance Industries in the production of telecommunication product and oil product uses different factor combinations. In such case, we segregate the two industry and put one unit which uses a factor combinations to other industries which uses similar factor combinations. Similarly, we put another unit which uses a particular factor combinations with those industries which uses similar factor combinations. So in this manner, segregation is done. Let us look at the input-output table. The input-output table shows the disposition of the total products and total inputs among the different industries. So basically it shows the use of the total products and total inputs of steel, automobile and oil in our example among these industries. Now we have already assumed that there are only 3 producing sectors and that the production of each sector is being used as input in all the sectors and also used for final consumption. So in the table, X1, X2 and X3 are total outputs of 3 sectors, that is steel, automobile and oil, and Xij is the amount of output of ith industry used up as intermediate input by the jth industry. So X11 implies that the output of the first industry is used as input in the first industry. Next, if we look at X21, this tells us that output of the second industry is used as input in the first industry. Similarly, X31 implies that output of the third industry is used as input in the first industry. In the same manner, X23 implies that output of the second industry, that is automobile, is used as input in the third industry, that is oil. X32 implies that output of the third industry is used as input in the second industry, that is output of oil is used as input in the automobile industry. The total output column gives the overall input and output of each commodity. The first column describes the input or cost structure of first industry. So if we look at the first column, it tells us what are the inputs which goes into the production of steel. So in the production of steel, X11 unit of steel is used, that is its own output, X21 unit of automobile and X31 unit of oil. If we look at the second column, it tells us that in the production of automobile, X12 unit of steel is used, X22 unit of automobile is used and X3 unit of oil is used along with its primary input, that is L2. In the same manner, if we look at the third column, it tells us in the production of oil, X13 unit of steel is used, X23 unit of automobile is used and X33 unit of oil is used along with its primary input L3. If we look at the input output table row wise, it tells us the demand for the output of that industry by the different industries as well as the demand for its output as final good. If we look at the first row, that is the steel industry, it tells us that the steel industry is being demanded by itself, it is being demanded by the automobile industry and by the oil industry for its intermediate inputs. Part of the output of steel is also being demanded as final good. Let us look at the second industry, that is the automobile industry. So the automobile industry is being demanded by the steel industry. It is also being demanded by itself, that is the automobile industry, and by the oil industry. Part of its output is also being demanded as final good by consumers. If we look at the third industry, that is oil industry, we see that the oil industry is being demanded by the steel industry. It is also being demanded by the automobile industry and by itself. Part of its output is also being demanded as final good by consumers. Let us assume hypothetically, for simplification purpose, that each unit of output of each industry has a price of 100. Say 1 unit of steel costs 100 rupees, 1 unit of automobile costs 100 rupees and 1 unit of oil costs 100 rupees. By doing in this manner, we are able to express all the entry in the above table in monetary terms. If we add each column, it will tell us the total costs incurred in producing 1 unit of output of a particular industry. So if we add the first column, it will tell us the total cost incurred in producing 1 unit of steel. In the same manner, if we add the second column, it will tell us the cost incurred in producing 1 unit of automobile. In the same manner, if we add the third column, it will tell us the cost incurred in producing 1 unit of oil. So let us frame the table in equation form. So output of the first industry is being demanded as input by the first industry, by the second industry, by the third industry, and also part of it is being demanded as final good. Output of the second industry is being demanded as intermediate input by the first industry, by the second industry, that is itself, and by the third industry. And also part of it is being demanded as final good by consumers. Output of the third industry is being demanded as intermediate input by the first industry, by the second industry, and by the third industry. Also part of its output is being demanded as final good by consumers. So in this manner, we can arrange in equation form. Let us proceed and discuss the technological coefficient matrix. Now from the second assumption of fixed input requirements, we see that in order to produce 1 unit of jth commodity, the input use of ith commodity must be a fixed amount, which is denoted by Aij. Now how is Aij obtained? Aij is obtained by dividing the units of goods of the ith industry used as inputs in the jth industry by the output level of the jth industry. Now A11 is the fixed amount of input of the first industry which is to be used in the production of the first commodity. Now it is obtained by dividing the units of goods of the first industry used as inputs in the first industry, that is X11, by the output level of the first industry, that is X1, or X11 is equal to A11 times X1. A12 is the fixed amount of input of the first industry which is to be used in the production of the second industry, and it is obtained by dividing the units of goods of the first industry used as input in the second industry by the output level of the second industry, or X12 is equal to A12 times X2. A13 is the fixed amount of input of the first industry which is used in the production of the third commodity, and it is obtained by dividing the units of output of the first industry used as inputs in the third industry by the output level of the third industry. A21 is the fixed amount of input of the second industry which is used in the production of the first commodity. It is obtained by dividing the units of goods of the second industry used as inputs in the first industry by the output level of the first industry. A23 is the fixed amount of input of the second industry which is used in the production of the third commodity, and it is obtained by dividing the units of goods of the second industry used as input in the third industry by the output level of the third industry. Similarly, the other fixed input requirements are obtained in this manner. We have already represented the input-output table in a system of equation. In all the three equations, wherever Xij is present, we are going to substitute it by Aij Xj. In case of the first equation, for X11, we are going to substitute it by A11 X1. For X12, we are going to substitute it by A12 X2. For A13, we are going to substitute it by A13 X3. all the terms having xij in the second and third equation are substituted in the similar fashion. Now if industry 1 produce an output just sufficient to meet the input requirements of the three industries as well as final demand of the open sector, its output level x1 must satisfy the following equations. The first equation implies that the output of the first industry, that is x1, which is steel, must satisfy the input demand from the three industries, that is the steel industry itself, automobile and oil industry, and also the final demand for its output by consumers, which include government and export sector. In the similar manner, the output level of the other two industries must satisfy the following equations. That is, the output of the second and third industry must satisfy the input demand from the three industries and also the final demand for the output by consumers. Moving all the terms involving variable xj to the left hand side, we have, that is x1, x2 and x3 in all the three equations. To the left hand side we have, so in this set of equations shows that we have moved all the terms having xj to the left hand side. Simplifying further, we are arranging the terms having common variable together. In the first equation, the common variable are x1. Similarly, in the second equation, we are arranging the common variable x2 together. Also in the third equation, we are arranging the common variable x3 together. Simplifying further, in the first, second and third equation, we see that we have taken common wherever possible. In the first equation, x1 is common between two terms. In the second equation, x2 is common between the two terms. And the third equation, x3 is common between the two terms. Rewriting the above equation in matrix form, we have, if we name the coefficient matrix by A, variable vector by X and constant term vector by F in notational form, we can rewrite the above matrix as AX equal F or A times X equal F. Now rearranging for coefficient matrix A, here we are going to split the input coefficient matrix A into two matrices, that is the identity matrix and the input coefficient matrix. After doing so, rearranging the above matrix in notational form, we have I minus A times X equal F. Here I minus A is known as the Leontief matrix. Multiplying both sides by the inverse of the Leontief matrix. Inverse of a Leontief matrix I minus A times the Leontief matrix is equal to an identity matrix, since multiplication of a matrix with its inverse will yield an identity matrix. Again, I times X is equal to X, since multiplication of a matrix with an identity matrix will yield the given matrix itself. So I times X in this case is equal to X. This equation is known as the Leontief input-output model equation. The equation will help us to find the output level of each of the three industries, that is the steel industry, the automobile industry and oil industry. Given the input requirements of the three industries and the final demand for each of the output of the three industries. As long as the Leontief matrix I minus A is non-singular, which implies that its determinant is not equal to 0, we are able to find its inverse and obtain the unique solution of the system. So this is the Leontief input-output model, an open model for three industries case, that is the steel industry, the automobile industry and the oil industry. In this way, the Leontief static input-output model shows what level of output should each of the three industries in our example, the steel, automobile and oil industry should produce, in order that it will just be sufficient to satisfy the total demand for their products. That is, the input demand by the three industries for the output produced by the three industries, as well as final demand for each of the output of the three industries. Let us now discuss the Leontief static input-output model. We have already discussed the three industries case. This is just an extension to cover the nth number of industries in an economy. In real world, the number of industries in an economy is very large. The Leontief static input-output model for n industries attempts to capture the interrelationship and interdependence between the nth number of industries in an economy. We have already discussed the introduction of the model, what is an open model and a closed model. We have already discussed the assumptions. Let us look at the input-output table. We know that the input-output table, as we have discussed earlier, shows the use of the total products and total inputs of the nth industries among the different industries. So the economy consists of producing sectors only, and that the production of each sector is being used as the input in all the sectors and used for final consumption. In this particular table, we have taken into consideration and included nth number of industries. In the table, x1, x2 and xn are total outputs of n sectors, and xij is the amount of output of the ith industry used up as intermediate input by the jth industry. Inj takes the value of 1, 2 to n. The total output columns gives the overall input and output of each commodity. We have already discussed earlier in the three industries case. The first column describes the input or cost structure of the first industry. X1 units of output of the first industry was produced by using X11 unit of the first good, X21 unit of the second good, Xn1 unit of nth good along with its primary input L1. The second column describes the input or cost structure of the second industry. So in the production of the second commodity, X12 unit of the first commodity is used, X22 unit of the second commodity is used, Xn2 unit of the nth commodity is used along with its primary inputs. The sixth column describes the input or cost structure of the nth industry. If an economy consists of 1000 industries, the nth industry will be the 1000 industry in an economy. So Xn unit of output of the nth industry is produced by using X1n units of the first industry, X2n unit of the second industry, Xnn unit of the nth industry, that is its own output along with its primary inputs Ln. Now if we assume that each unit of output of each industry has a price of 100 rupees, say each unit of output of the first industry, second industry and nth industry has a price of 100 rupees. By doing this manner, we will be able to express the entry in the above input-output table in monetary terms. By doing so, we will be able to compute the total cost of producing each unit of output of the different industries. By adding this column, we will be able to compute the total cost of producing each unit of output of the first industry. In the same manner, by adding this column, we will be able to compute the total cost of producing each unit of output of the second industry. Similarly, by adding this column, we will be able to compute the total cost of producing each unit of output of the nth industry. Let us look at the input-output table row-wise. Now this row tells us that the output of the first industry is being demanded as input in the first industry, that is itself, by the second industry and by the nth industry. Part of the output of the first industry is also being demanded as final good by consumers. Again, this row tells us that the output of the second industry is being demanded as intermediate input by the first industry, by the second industry, that is itself, and by the nth industry. Part of output of the second industry is also being demanded as final good by consumers. Again, if we look at this row, it tells us that the output of the nth industry in an economy is being demanded as intermediate input by the first industry, by the second industry, and by the nth industry, that is itself. Part of its output is also being demanded as final good by the consumers. Rewriting the above input-output table in equation form, we have already discussed the technological coefficient matrix in case of three industries. From the second assumption of fixed input requirements, we see that in order to produce the first unit of jth commodity, the input of ith commodity must be a fixed amount. Now Aij, which is the fixed amount of input of the ith industry, which is to be used in the production of the jth commodity, is obtained by dividing the units of goods of the ith commodity used as input in the jth commodity by the output level of the jth commodity. Now A11, that is fixed input requirements of the first industry used in the production of the first commodity, is obtained by dividing the units of goods of the first industry used as input in the first industry by the output level of the first industry, or X11 is equal to A11 times X1. A12, that is the fixed amount of input of the first industry which is to be used in the production of the second industry, is obtained by dividing the unit of goods of the first industry used as input in the second industry by the output level of the second industry. A1n, which is the fixed amount of input of the first industry which is to be used in the production of the nth commodity, is obtained by dividing the units of goods of the first industry used as input in the nth industry by the output level of the nth industry, or X1n is equal to A1n Xn. An1, which is the fixed amount of input of nth industry which is to be used in the production of the first commodity, is obtained by dividing the units of goods of the nth industry used as input in the first industry by the output level of the first industry. A12, which is the fixed amount of input of the nth industry which is to be used in the production of the second commodity, is obtained by dividing the units of goods of the nth industry used as input in the second industry by the output level of the second industry. Similarly, ANN, which is the fixed amount of input of the nth industry which is to be used in the production of nth commodity, is obtained by dividing the units of goods of the nth industry used as input in the nth industry by the output level of the nth industry, or XNN is equal to ANN times XN. Now in all the nth equations, wherever Xij is there, that is X11, X12, X21, Xn1, Xn2, Xnn, we are going to substitute it by Aij. Let us do for the first equation. Now in place of X11, we are going to substitute it by A11 X1, since X11 is equal to A11 times X1. In the same manner, for the second term X12, we are going to substitute it by A12 X2, since X12 is equal to A12 times X2. Now for X1n, we are going to substitute it by A1n Xn, since X1n is equal to A1n times Xn. In the same manner, all other equations in the set of nth equations, wherever Xij is present, we substitute it by Aij Xj. By doing so, we obtain this set of equations. If industry 1 produce an output just sufficient to meet the input requirements of the n industries as well as final demand of the output sector, its output level x1 must satisfy the following equation. Now the first equation implies that the output of the first industry must satisfy the input demand from the jth industry, that is the first industry, second industry and the nth industry. It must also satisfy the demand for it as final goods by consumers. In a similar manner, the output levels of other industries must satisfy the following equations. Now moving all the terms involving variable xj to the left hand side, we have, that is moving all the terms highlighted by yellow color in this set of equations to the left hand side. By doing this manner, we obtain this set of equations. Let us simplify further by arranging all the terms in each equation having common variables together. In the first equation, we have two terms having common variables, that is x1. In the second equation, we have two terms having common variables, that is x2. And in the nth equation, we have two terms which have common variable, that is xn. Let us simplify further by taking common between two terms. In the first equation, we have x1 as common variable between the two terms. In the second equation, we have x2 as common variable between the two terms in this case. And in the nth equation, we have xn variable as common between the two terms. Now rewriting the above set of equations in matrix form, we have, now if we name the coefficient matrix by A, the variable vector by X and the constant term vector by F, we have AX equal F or A times X equal F. Now rearranging for coefficient matrix A, we have, now here we split the coefficient matrix into two matrices, that is the identity matrix and the coefficient matrix. Again rewriting the above matrices in notational form, we have I minus A times X equal F. Now I minus A is known as the Leontief matrix. Now multiplying both sides of the equation by the inverse of the Leontief matrix. So here we have multiplied both sides. Now inverse of Leontief matrix times the Leontief matrix is equal to I. Since multiplication of inverse of a matrix with a given matrix will yield an identity matrix. Again multiplication of an identity matrix I with a given matrix will yield the given matrix itself. So I minus X in this case will yield the variable vector X. Now this equation is known as the Leontief input-output model equation. Now given the input requirements of the nth number of industries in an economy and also the final demand for each of the output of the nth number of industries in an economy, we will be able to find out the output level of each of the nth number of industries in an economy. Now I minus A is the Leontief matrix, X is the variable vector or output vector, F is the constant term vector or the final demand vector. As long as the Leontief matrix is non-singular, which implies that its determinant is not equal to 0, we will be able to find its inverse and obtain a unique solution of the system. So this is the Leontief static input-output model for n industries case.